So what do we know from the graph? So I already added some things here, right? Just some booms. Like if you put this into Desmos, there'd be points at these spots. Because Desmos knows you want them, right? And so do I. So I added them for you. So you tell me, what do we know about this before we even start thinking about how to make it into equations? Let's just list the things that we know about this parabola, because that's going to be helpful. Give me something that you know about this parabola. One thing at a time. Give me one thing. The A is negative 2. How do I know that? It went over 1, down 2. Right? So that's a negative 2A. I heard something else. What else do we know?
Vertex.
The vertex is what? Negative 1, 18. That is true. What else do we know by just looking at this graph? Some x-intercepts. And they are what? Negative 4, 0. And 2, 0. So, absolutely correct, right? And anything else? I see a couple other things. Y-intercept, very good. We have a y-intercept. We sure do know a max. So what's the y-intercept? 0, 16, right? So yeah, our vertex, this is our max. Good. Anything else? There's one other thing that we usually label a lot.
Symmetry.
Yep, axis of symmetry. Look at all the things we know, right? Our axis of symmetry is x equals negative 1. Okay, so look at all that stuff I know, right? Now that I've collected my information of what I know, for 2 out of the 3 of these equations, all I got to do is plug in. Now the third one we'll get to. There's a little more work that has to be done. But think about it. I just need to know my A, my H, and my K, and I have them. The A is already labeled, right? What's my A?
2.
Negative 2. Now, this is why, even if I give you the forms, you got to know what they are. So, for instance, you got to know what H and K means. What is HK? What does it represent? XY of the vertex. So it's this right here, right? HK is right here, right? So I know my H and my K, right? And I can plug them in. So it would be X, and then it would be minus 1. So plus 1. And then plus K, and our K is? Plus 18. We don't flip that one. And there you go. You have your vertex form, and all you had to do was collect some information and plug it in. Okay? Question?
How do you get the y-intercept 0?
Because that's where it crosses the y-axis, right here. And that doesn't come into play yet. Like that, we didn't use that piece of information yet. But yeah, 0, 16 is where it crosses the y-axis, yeah.
You not put 18 because it's outside the parentheses?
Exactly. Think about the form. This minus tells me to flip things. This plus tells me leave them alone. Okay. Same thing here. I have these minuses, so I'm going to have to flip those numbers when I get there. Okay? All right, intercept form. Well, let's see what we have. We know our A. Our A is our A is our A, which is negative 2. And then I have these 2 parentheses I need to fill in. It's going to be x minus p and x minus q. Again, it's great if I'm going to give you this formula, but if you don't know what p and q represent, it's not going to be very helpful. What is p? What is q? Our x-intercept. So this is my p, and this is my q, right?
It doesn't matter which one.
It does not. That you could say q and p if you wanted to. Okay? So x minus 4. That's really plus 4. See how it flips the sign? And then x minus 2. Okay, now I have intercept form, right? Haven't really done too much math other than just plugging in what I know. Now, for standard form, it just does require some algebra, okay? Because there's no way to get your b value by looking at the graph. There's no, you can find your A, you can find your C, but you can't find your B by looking at the graph, at least not just by looking right at it. You could solve for it somehow. But what we're going to do to get our standard form, if you're asked for standard form from a graph, is you're going to find intercept form first and then convert it. All right? So we can convert from intercept form. All right? So we're going to convert from intercept. Because we know how to do that, right? If we know one, we know the other. Okay, so our intercept form was y equals negative 2 times x plus 4 times x minus 2. Right? And we want to turn that into something that looks more like this. It's two binomials to a trinomial. Well, we know how to do that. How do I go from two parentheses to a bigger thing? Foil or box, right? I just foil or box this. Now, the negative 2 we deal with at the end. If there's ever a number out front, you deal with that at the end. So really, I just need to foil the two binomials and then worry about the negative 2. So I'll do FOIL right now. First, outer, inner, last. So y equals negative 2, and then whatever that turns out to be, right? And it's going to be x times x is x squared, plus 4x minus 2x, that's plus 2x, and then minus 8. That middle part where I just did it in my head, you can do that if you want to. You don't have to write minus 2x plus 4x, take another step to combine them. If you can see the like terms in your head, just combine them, right? Plus 4x minus 2x, that's plus 2x. All right, now let's distribute. We got to distribute that negative 2 that's on the outside, and then we'll be done. So that would be a negative 2 all the way through, and we get y equals negative 2x squared minus 4x plus 16. Well, I had plus 2x and a minus 2. Okay. Now, a couple things to notice here. First, remember I said you can't get standard for just looking at the graph. See this minus 4x in the middle? There was nothing on here that told me I was going to get a minus 4 for b. So that's why you can't just look at a graph and give me standard form. You have to find intercept first and then convert. Okay? But there are two things you can use to at least check your work, because A and C are given, aren't they, right? What does A represent? Or abstraction and reflection. So we had a negative 2 up front. Does that match the graph? Yeah. What does C represent? Y-intercept. Our y-intercept. We had a 16 at the end. Does that match the graph? Yeah. Right? So you can always use them to check your work, but you have to do a little bit of work to get your standard form from a graph. Okay? Don't just say, oh, vertex, or, that gives me my B. You have to either solve for your B or convert. Okay? Make sense? Yeah. Okay. So we're going to move on from the world. Okay, so what we're going to do today. So last class, we had intercept form, and we graphed it. Now we want to write it. We want to be able to write an intercept form. And we're going to be starting with other forms. So say I give you standard form. Can you change that to intercept form? Say I give you vertex form. Can you change that to intercept form? Okay? So first we're going to go from standard to intercept. Okay? And we're going to do it a couple different ways. One way is easier in some situations, the other way is easier in other situations. Okay? So before we do, let's just kind of make some sense of what we're doing here, right? So we've done this, right? Like say you have x plus 7 and x plus 3, and you want to go to standard form. Well, what would you do? Box or foil, right? So if we foiled this, first, outer, inner, last, we would get x squared plus 7x plus 3x, so that's plus 10x plus 21. Okay? So that's going from intercept to standard. Now, what we're being tasked with here is to go the other way. Right? We want to go from here to here. We want to go backwards. So we have to find these two numbers, these pieces, somehow from 21 and 10. Okay? Now, this is where these puzzles that I've been forcing you to do on homework that had no context whatsoever come into play. Right? The puzzles that we've been doing are going to help us do this. All right? And it looks like this. I like to call it the magic X. You might hear it called a diamond puzzle in other classes. I think magic X is more fun because it's quite magical. This magic X. So what you do to go this way, right? Like let's say I started out with x squared plus 10x plus 21, and I wanted to know what does that equal in terms of intercept form. Well, I make a magic X. Question.
Okay, so can we just do it? Like, we know that there's two x's, like x.
Yep, so hold on, pause, because that's important. I want everyone to share your knowledge here. How do you know that there's two x's?
That's the formula.
Right, but why isn't it 2x and x? Why is it x and x? Because we're trying to get to x squared when we FOIL, right? We're thinking like reverse FOIL. Okay. Now, then
we see what 2 multiplies gives us 21.
But it can't just multiply to give us 21. It also has to add to give us 10. So we use the x as a framework for that puzzle. Yeah, this is an easy one. They're not always going to be easy. So we give ourselves a framework so that when it's a harder one, we have a framework, right? And what we do is we put a times c at the top. Now, a here is what? 1. So it's really just c at the top most of the time. And our c is what? 21. And our b is 10. And now we do these puzzles that we've been doing where we say, okay, multiply to get that, add to get that. And yeah, we know this one because we already did it, right? 10. But so it would be 7 and 3. That multiplies to give me 21 and it adds to give me 10. It checks my boxes, right? Okay, so I just throw those in. Now, it's very important at this point that you do not flip signs. Everybody wants to flip signs at this point. When you're going from x to equation, do not flip. You will only flip when I'm asking you for the x-intercepts. For instance, now that you've done this, you could say, hey, my x-intercepts are -7, 0, and -3, 0. That's when you flip, when I'm asking you about the graph. This is when you flip. Okay? You do not flip from x to equation. Okay? And we're going to practice this a good deal. Now, this is the best method when a is equal to 1. And we're just going to have a be equal to 1 today because we need to start slow with this process. But a will not always be 1. It could be 2. It could be -3. And when that's the case, you're going to want a different method. And that's what I'm going to show you next, okay? All right, so let's look at the same example, but the good thing about me showing you this method is 1, you're going to want it when a isn't 1. And then 2, this is kind of why the puzzle works. And I don't like to just give you tricks without showing you why they work. We're not here to learn tricks. We're here to learn concepts, right? So if I think about it this way, reverse box, right? So normally we use a box. We have parentheses, and we fill out the box, and we get an answer. But what we're doing now is we have the answer. We know that the result of this box is x squared plus 10x plus 21, right? We're going to go backwards. Now, what do we know? Well, I know what usually ends up in this top left box. X squared. And what usually ends up in the bottom right box? The number, right? So the reason we're adding to get 1 and multiplying to get another is that's what these two numbers have to do to make this make sense, to make the box make sense, right? These two numbers have to both multiply to get you 21 and add to get you that 10 that we get from our like terms. Okay? So we know we've done this a few times now. What two numbers are they? 7 and 3. So this must be 3x, and this must be 7x, right? And now you just kind of do some reverse math, right? What times what must have gave me x squared? X and x. X times what gives you 3x? 3. X times what gives you 7? Plus 7. And then 7 times 3 is 21. So it works, right? This is why the diamond puzzle or Magic X works, right? So we know this equals x plus 3 and x plus 7. And also, you can use this to check your work, right? Because, or you could use FOIL to check your work, right? Because if you went from here to here, you should be able to go backwards, right? So if you want to check your work, just FOIL this back out and make sure you get the original. Yes?
Why did the x-intercept uplift the sign? Usually we don't flip it.
Because the x-intercept here, why did it flip here? Because the x-intercept happened when y is 0. And if you have y equals x plus 7 and x plus 3, well, now you're telling me x-intercept, so y is 0. 0 equals x plus 7, x plus 3. Okay, so what would make that true? If I had a negative 7 or a negative 3. Those are the only things that would make this 0. Negative 7 plus 7 would be 0. Times this would be 0. Negative 3 plus 3 would be 0. Times anything would be 0.
Yeah, but usually when we like find the P and Q, we don't flip it.
Because these aren't the P and Q. The P and Q are your x-intercepts. This is just the equation. And that's a key point of confusion, so I'm glad you brought this up. These are not your P and your Q. They're the flipped version of your P and your Q. These are just what you put into the equation, and then you pull your P and Q out. Then you say, okay, negative 7, negative 3. Okay?
Yeah, these are the P and Q. What?
Nope, this is my P, and that's my Q.
But usually like when you want to do that, you find the P and Q, it's plus 7 plus 3, and then you write the x.
Well, we're going backwards now, right? We're going backwards, so that's why it happened in the other order. Okay?
If it was like that, it would be like.
So if I started with this, I would go to this. But I'm starting with this, so I'm going that way. Okay? When you practice it a lot, it'll make more sense. Okay, let's give you some examples to work on. And we're only going with an A of 1 today, so it won't be too bad. You can use your Magic X every time. Okay, so let's say you have y equals x squared minus 6x minus 16, and you're trying to convert it to intercept form. So you're trying to give me this parentheses situation, right? So you need to make a Magic X, and you put your C on the top, your B on the bottom, and then you solve the puzzle, I should say. Okay, so give that a shot, and then we will come back together and do a couple more examples, and then I will show you one other thing. All right, so what goes on the top? Negative 16. What goes on the bottom? All right, so when you're doing these, right, you want to first think about the signs. If I multiply to get a negative, what must be true about the two numbers? One of them's negative, one of them's positive. Then I think to myself, okay, 16. Well, what multiplies to give me 16? 4 and 4. 4 minus 4 is not 6. What else? 8 and 2. Well, 8 minus 2 is 6. That might work. And then I just plug it in to make the signs work, right? I want a negative 6, so I'm going to go negative 8 and positive 2. Okay? So you just kind of have to do a little bit of side work. Use the multiplication chart to help you if you're not great with multiplying, right? Use your calculator. So x minus 8 and x plus 2. Okay, next up. Y equals x squared plus 11x plus 10. And in fact, I'm going to give you 4 examples to work on. Y equals squared. I'll stop talking that so as to not confuse you. All right, so you got 3 more examples there. The second 2 have a little bit of a trick to them, and I gave you a little hint. Okay, so here, I would make a Magic X. What would go on top? 10 will go on the bottom. Two numbers that multiply to give me 10, add to give me 11. 10 and 1. And it's that easy. Y equals x plus 1 and x plus 10. Boom, you have intercept form. Okay? Now, these are a little trickier, and there's a reason that I left the space here. I wasn't just writing poorly like I always do. What can go in the middle to make this a little easier on us? Plus 0x, because that gives me a b value, and now I can do the x, right? And I didn't change anything because 0 times x is just 0. I didn't actually add anything here, but now I have a -9 and a 0 for my x. And now I can think about this and be like, all right, what multiplies to give me -9 and then adds to give me 0? -3 and +3, right? So this becomes y equals x minus 3, x plus 3. And you'll notice anytime you get x squared minus a perfect square, you get something that looks like this. And we'll talk more about that. All right, last one. What am I missing this time? C. So I'm just going to add a 0 at the end, right? And now I have my magic x. I got 0 on top, 5 on the bottom, two numbers that multiply to give me 0 and add to give me 5. 5 and 0. So this becomes y equals x plus 0 and x plus 5. And this can actually simplify. X plus 0 is just x. So this becomes y equals x times x plus 5. And guess what? This is called factoring, when you just pull it out. Like we talked about before, x, if you FOILed this back through, or you distributed it back through, you'd get x squared plus 5x.
Whoa.
That's okay. That's okay. If you understood it that way. Hold on, we have one more thing. So I gotta get through one more thing. We only talked about converting from standard to intercept. We gotta talk about converting from vertex to intercept, right? So we're gonna convert. We have 5. We're going to convert from intercept form, convert to intercept form given vertex form. So we're going y equals a times x minus h squared plus k, and we're trying to get to y equals a times x minus p, x minus q. Now, there is no direct way to do this, okay? You can't go just from vertex, but that's okay, because first we convert vertex to standard, and then we have it in standard, and we convert standard to intercept. And I'll show you an example. Okay? So you can't go directly. So you go from vertex to standard, and then from standard to intercept. Okay? So this is what it looks like. I'll give you an example. Say you have y equals x plus 3 squared minus 4. So I want to get that into intercept eventually, but first I got to get it into standard. So if I remember, to get from vertex to standard, I expand. So this becomes x plus 3 minus 4. Then I FOIL or box that so I can figure out what that is. First, outer, inner, last. Y equals, and this would be x squared plus 3x, so that's plus 6x. Plus 9 minus 4. 9 minus 4 is 5. So y equals x squared plus 6x plus 5. Okay, so now I've gotten it into standard form. Y equals x squared plus 6x plus 5. I still want to get to intercept. So I make a magic x. I told you it was a full class today. And I do 5 on the top, 6 on the bottom. Two numbers that multiply to give me 5, add to give me 6. 5 and 1. So I get y equals x plus 1 and x plus 5. All right, so just real quick, what we did here is we started with vertex form. We converted to standard form. And then we converted that to intercept form. Okay, so that's your process. All right? There you go. 2 minutes to spare.